Hello, everyone. Thank you for joining us, watching us at this time of the day, morning, evening, afternoon, whatever
Yeah.
time it is. It is it is late evening, Marco's time, almost night. Hey,
Yeah.
Marco, how are you doing?
Hi, Hareza. How are you doing?
Good, good. Thank you. Really
Nice.
appreciate your time having you here, and it's a wonderful opportunity for everyone to enjoy learning from your thoughts. I'll let you introduce yourself, but before that, let me just explain that. The thing is that Marco doesn't really need introduction, but if you haven't if you haven't ever came across their website, which is very unlikely if you are working in the world of Power BI, SQL BI is like fantastic website. You can learn everything about DAX you want there. They recently released the second edition of their DAX pattern book. Fantastic book. I highly recommend it. You have it, Marco, over there. Yep, that's there. And another thing I recommend you to do it is that they also have the video course related to that, which is already on like more than 70% discount. So make sure go ahead and check this out.
If you get all because you can get one pattern, but if you get all of them, then you can spend a lot of you can
Yeah.
get a lot of discount if you get the collection of all the patterns. So
Yeah, so definitely recommend it. If you want to learn DAX, there is no better resource
by the
than
way, the
learning from
website is
Marco.
completely free. If you navigate through the website, it's
Yeah,
completely free. So it's
yeah,
just
yeah.
the
Lots
video.
of free articles, lots of videos, their YouTube channel, everything fantastic. Okay,
Thanks.
I'll let you introduce yourself, Marco, please.
I mean, Reza already said everything, but my name is Marco Russo. I work in SQL BI, and we produce content about Power BI, DAX, and data modeling. We focus especially in DAX and data modeling. So as soon as you go to Power Query or visualization, administration, scripting, no, we just do DAX and data modeling. This is what we're specializing in.
Yep.
Okay.
Fantastic, thank you. Marco will start his session quickly. The only thing about questions is that if you have any questions, feel free to write it in the chat window in the YouTube channel.
Yes.
I'll be monitoring that and passing those questions to Marco. And without further ado, I just hand it over to you, Marco. You can share your screen and go from there.
So let me go to my screen, and here we go. So let me remove this. Don't worry, I don't have too many slides. This is the very, very long title of the session, just because I tried to explain what I wanted to do in this session. But the idea is that we will use DAX Studio to analyze the metrics of the model. The metrics of the model is a feature that we will see in DAX Studio, which is an integration of a tool called VertiPaq Analyzer, which retrieves statistics about what you have in memory for your model. So when you import data in memory for your data model, and you want to understand how you are consuming the memory, and you also want to get information that could be useful for performance optimization, this is the tool that you need. This tool provides a lot of numbers that I will try to explain. So I will try to provide you information about what you need to know to understand the meaning of the many numbers we will see. And we will try to optimize a model where we have something that could be removed and optimized. I suggest you, once you maybe don't try the same thing that I do online, because you could easily get lost in a few seconds. But maybe when we will get to the recording, or after the session, you can just try the same tool with your model, and you will find something that you didn't realize that could be saved. So we already made the introduction. So SQLBI.com, you can find a lot of content. I can skip the slide, and I have a very small number of slides that are here just to help me introducing a few concepts, but I will spend most of the time doing just demos. So the tool that we use as a starting point is DAX Studio. The latest version of DAX Studio has a feature that I will show you in a moment, but DAX Studio by itself is an open source free tool that you can download from daxstudio.org. And if you have the latest version of Power BI and you install the latest version of DAX Studio, there is an integration of DAX Studio in Power BI. So let me show you. I already downloaded and installed DAX Studio in my machine, of course. And now I move to this file that I'm going to open. And before I open the file, I want to show you that the file I'm going to open, the Contoso PBX file, is a file that is 243 megabytes in my storage, in my computer. So I double-click the Contoso, and I open Contoso. So I know that this file, I mean, it's not too large, but it's not actually very, very small. And when I look at the content of Contoso, I see that there are information that could be useful for my report. I have sales, I have 12 million rows in a table called sales, so I have a lot of transactions, a lot of products, and so on. So I imagine that, well, this model is not very small, so maybe there is something I can optimize. And but in general, it could be useful to understand why I'm consuming so much memory. So as you see, I have a model here. Now the model is something I could use for my report. And so, for example, if I include here the product color, and then I include the sales quantity, just let me see if I am able to get this. So I put this to sales quantity. You see that here, once I have this information here, I have all the numbers here. And if I take a look at the model, I can see that here in sales, the sales table, you see in this corner, sales has 12 million rows. Okay, so the size of this database is 12 million rows in the largest fact table, in the largest table, which is the sales table, and we don't have big tables. The other tables are 10,000, 20,000 rows, no more than that. And here we can see also the diagram that explains that basically I have what we call a star schema. Actually, this is a snowflake schema. The sales is the table in the middle, and there are other tables that are much smaller around. Now, 12 million rows to 140 megabytes means that every row has a cost in memory, sorry, a cost for the file that I have seen that is around 20 bytes for each row of the sales table. This is what I can expect. But if I take a look at the content here, you see that there are columns that are different. There are columns that pretty much have the same value in every row, whereas there are other columns that have a different value in each row. Like, for example, this online sales key, the column has different numbers. If you scroll down, you see this number always changes. And the other columns, it depends. There are columns that change often, like, for example, the order number is another column that changes often. But the other columns, you see that there are many rows with the same numbers. This is because the rows are, sorted in the table so that they appear, similar rows appear together, even though originally they were in different places. So this is my model. This is my starting point. I know that I want to know more about my model, and because I installed DAX Studio, you see that now DAX Studio is available here. Now, if you start DAX Studio without doing this start button, without using the button in Power BI, what happens is that DAX Studio asks you where you want to connect to. And so, for example, I could connect it to analysis services, I could connect it to Power BI, but you have to open Power BI before doing the connection. You cannot connect DAX Studio to a PBX file. You can connect DAX Studio to an open instance of Power BI desktop. So you have to first open Power BI, then open the Studio, then do the connection. And we have to spend time waiting. So now we have the ability within Power BI to click just one button. And when I click this button, DAX Studio opens and automatically connects it to Power BI, to this instance, this particular database with Power BI, which is Contoso. And you see that the name of the tables are the same. You just can notice that the name here is a strange name, is an internal identifier to tag this database internally. You can ignore this. There are no, it is not important. But when I go here in advanced, I have this section where we have import matrix, export matrix, and view matrix. View matrix is the first feature that I want to show you. Now, before clicking this button, just let me talk quickly about DAX Studio. So DAX Studio is a tool that you can open, you can use to connect it to Power BI, and you can use to write queries, to export data, to analyze the performance of a single query. For example, if I write evaluate product, I can run this query and I can see here in the result the content of the product table that I have in Power BI. I could also export this to a file. I could export the content of a table to a file. You can also export the content of all the tables or a few tables in CSV files or SQL Server tables. So let's say DAX Studio has many tools that helps you write in DAX code, but also to do something with the data that you have in Power BI. What we want to do now, we want to know more about our model, and so I click on View Metrics. Let's see what happens. Now, View Metrics internally uses a library which is called VertiPaq Analyzer. It's a library, open source, available as a package on NuGet. So for those of you that are developers, you could use the same library for any other tool you want. If you have an idea for a new tool for Power BI, you can just reuse this library. It's completely free and open source. You can also contribute and add features if you want. So View Metrics opens this pane, which is called VertiPaq Analyzer Metrics. I can zoom this a little bit, so we have a better font to see what is here. You see there are several tabs here: tables, columns, relationships, partitions, and summary. Let's start with the summary. Summary says the total size is 300 megabytes. Oh, wait a minute. It was 300 megabytes, the PBX file. Why we have 300 megabytes? Because the PBX file has an additional compression that is get lost once you load the data and you import the data in memory. One of the reasons is that the dictionaries, which are part of the structure of the data, are not compressed once you load the data in memory, whereas when you save the PBX file, that part is compressed. For performance reasons, that part is not compressed in memory, whereas other parts of the data are compressed. So basically, it is almost always a little bit bigger than the size of the PBX file, the cost in memory. But this number is telling me I have 300 megabytes of the RAM of my computer that are used to just get the data in memory for my Contoso file. Okay, so this is the situation, 300 megabytes. Okay, good. Now, I know that I'm spending 300 megabytes, but where am I spending these 300 megabytes? So here we usually start with this visualization, which is tables.
Sorry to interrupt, Marco.
Yep.
The question is is it megabytes, bytes, or bits?
Okay, so 300 megabytes. Okay, when you see, you're right. It should be uppercase B. That's a good point, because this the lowercase. I have to let me write a note.
Adding a feature in DAX Studio
instead of B. Okay, so I will. Before shutting now, I will copy this. It's a good point. Good point. That is always megabytes. Okay, we talk about here is megabytes, whereas the numbers here are in bytes. Okay, so the number here that you see for these columns that I'm going to explain, so table, column size, data, dictionary, hierarchy size, all these numbers are bytes. Okay, so you see that we have 312 million of bytes. So this is something. If we had to do megabytes, we should divide by 1 million and something. It's 124 multiplied by 124. However, let's say we have something more than 300 megabytes. And if I look at the list of the tables, I see that most of the data, most of the memory is consumed by a single table called sales. Then I have customer product data and so on. Now, you see that there are different columns. So let me start to explain what is the meaning of these columns, because actually these are important information. And the first information that is very, very important is the cardinality. The cardinality is a column that has a different meaning depending on the object that we analyze. For a table, The cardinality is the number of rows of the table. Okay, so the number you see here, 12,527,442, is identical to the number we have seen here. This corner here, we have the very same number, because this is the number of rows of the table. Now, you know, when I click on a column in Power BI, here we have an additional information, which is the number of distinct values for the column. So the number of rows of the table is always the same, but in this column, order line number, we have almost 5,000 unique rows distributed across 12 million rows. So you can do the math. How many rows have the same number? It depends on the data distribution, but you can do the math. Now, this information, the cardinality of a column, the number of unique values of a column, is another important information. And because it's important when you do performance optimization, when you analyze the cost for a iterator of a column. Now, when we drill down here, when I open sales, I expand this list, having looking at the list of the columns of the table. So we have here the details of all the columns of the table sales. And for each column, we know what is the cardinality of the column. The cardinality is the number of unique values. And you see that order line number has 4,972 unique values. So the cardinality of this column is almost 5,000. But it's interesting to see that there is a column, online sales key, which has the same cardinality of the table, which means that there is a unique value for each row of the table. Indeed, this is the primary key of the table sales. And so it has to have a unique value for each row, which is fine. There is only one problem. The memory consumed by each column is different. So when you think about a relational database like SQL Server, and you see, oh, this table has this cost in memory, or this cost in the storage, you can easily divide that number by the number of rows, and you know what is the cost of each row, because that database is usually stores data by row. But here we have a database that is completely different. When you load the data in memory, when you import the data in memory in Power BI, the data is compressed and stored by column. This storage is called, the storage engine that stores this compressed data in memory by column is called VertiPaq. So far, I just told you VertiPaq Analyzer, but what is VertiPaq? So I go back to the slide 1 second. Because when you have Power BI or when you have analysis services, the engine is the same. You create a model and you have an option. You want to import data or you want to connect with direct query. From a DAX standpoint, it is just a choice between two different storage engines. If you store data in direct query, the storage engine is SQL Server or your relational database. If you import the data, no matter what the data source is, the data is in memory and is managed by VertiPaq. So for the remaining part of the session, we only focus on this case. We import data in memory. If you're using direct query, you can shut down, because we don't see anything that is useful to you, because we don't have any information about what is stored on SQL Server. But if you import the data, this is what you want to know. So VertiPaq is this engine that loads the data in memory, compresses the data, but the data is stored by column. And the library and the tool that analyzes the statistics about how the data is distributed in memory is called VertiPaq Analyzer. I will show you later that we actually have a separate tool called VertiPaq Analyzer, which is able to read the same information I am collecting in the studio, showing additional information that are not visible in DAX Studio itself. So DAX Studio extracts more information than what it displays just in the visualization pane that I showed you. So in order to understand why it is so important to think about columns and not rows, let me just quickly show you how VertiPaq works. When you have a table in a relational database, usually you store data row by row, which means that a block of contiguous rows is stored in a certain area of the storage that is called the page in SQL Server. And so every page in the relational database has a number of rows, but all the columns of those rows are close each other. Now, with a columnar database, the data is stored column by column instead of row by row. What does it mean? It means that imagine to create different files on your storage, and in one file you store only the column ID. In another file, only the column name. In another file, only the column address. How do you retrieve a certain row? Well, you open each file, you go to the, row number 11 of that file, of each file, and you rebuild the row number 11 of your entire table. Very expensive to do this job. However, the advantage of a columnar database is that when you want to just sum the revenues, which is the sum of a column, you don't have to read the content of the columns that are not involved in your report. And because in a report you almost never use all the columns of a table, you just group by a few columns, filter a few columns, and some other columns, you don't need to read all the data of your model. And so this is the idea behind the columnar database. You just query the column that you need. Now, there are pros and cons in the different storage techniques, but the idea is that columnar storage is better for reporting. But whereas it is absolutely not good if you have to do read, delete, write, update operation over the database. Now, compression. So the data, I will not spend time now describing how the compression works, but let's say that there is some magic. The data is imported by your Power Query transformation, and then at a certain point it's stored column by column in memory with a compression that I will explain you in a moment. But let's say if I look at the column, one way to compress the data is that if you have a contiguous rows with the same value, why storing the same value multiple times? You could store just value Q1, repeat the same value 310 times. And so you could have a number that says, oh, I want to repeat this value many times. Of course, it saves you a lot of RAM if you have a small number of unique values. Whereas if a column has a unique value for every row, it is counterproductive to use this technique because the column, the number will be always 1. You will always have one duplication of the same value, but you just need more data to store that additional one number. And so this is just a description that every column has its own run length encoding compression, which is one of the two types of compression. If I have a column that doesn't have any contiguous duplicated value, so the column is stored as is. So the compression is applied if there is an advantage doing that. Otherwise, the column is not compressed at all. All this information are available in the pane that I will show you in a moment. The question?
Yes. Question is that, can you explain what materialization is?
Yes and no. The materialization, okay, I try to simplify the idea.
It's Oliver. He's asking, does it mean the refresh time?
No. Think about this. Power BI now is showing me the content of the table, right? So I can see the data as it was a simple table in SQL. However, in memory, the data is stored in a completely different way. In order to display the data has to be uncompressed, and we call this operation, uncompressing data, is called materialization. Now, if I have 12 million rows, I hope I don't have to materialize 12 million rows. Okay? Indeed, Power BI is smart enough to uncompress and materialize only the rows that I'm showing in this moment, in this window. You see that if I scroll down, I see other rows, but what is happening behind the cover, when I'm scrolling, Power BI asks for the next 500 rows, or 1000, depends. And only those rows are materialized. Now, this is when everything goes well, but when you create a calculation that for some reason requires some bigger materialization of the table, then you could be in trouble. And one of the common mistakes in DAX that could create performance issues is to create calculations in DAX that enforce the materialization of the table, creating a huge performance issue and a huge memory issue. Because one thing is having 200 megabytes or 300 megabytes of compressed data, but if I have to create the materialized version in memory of 12 million rows, I need a few gigabytes of RAM. Because do the math. If you have 20 columns, you have a string, a date, and this and that, you easily have to spend 100, 200 bytes for each row. Uncompressed data, you need 1 or 2 gigabytes. So this is the idea.
Great.
The materialization is something that is required at a certain point. We have just to try to reduce it at the minimum that is necessary. Now, we will not talk too much about this because at the moment is a little bit complex, and we want to focus today on these numbers. But when you optimize DAX, that is one important concept to understand and to learn. So I went back to DAX Studio now, and if you remember, we said, okay, so every column is compressed in memory in a separate area of the memory with different techniques. So every column can have a different type of compression compared to other columns. But because every column has a compression that depends on the distribution of the data in that column, what happens is that the size of the column, so the amount of RAM required to store the data of that column, depends on two things. One, the number of unique values of the column, what we call the cardinality. That for the column is the number of unique values in the column. Two, the distribution of the data across the table. Think about this. If you have two values, yes and no, in a column, but you have in every row a different value. You have yes, no, yes, no, yes, no, yes, no. There is no compression possible. Even though you have only two unique values, the column cannot be compressed because the only compression technique used by VertiPaq is to compress contiguous rows with the same value. You could say, but there is a pattern. A, B, A, B, A, B is a pattern. I can compress this. No, this is not a compression that can be done in VertiPaq, okay? Because of that, when you import your data in memory, VertiPaq tries to change the sort order of the entire table, actually of the rows that are read in a single segment, but this is a detail. But you can imagine you have the table is sorted because you cannot sort one column in a different way than another. So the position, the row number 2 has to be the row number 2 in all the columns. But you can change the rows in the table. You can move a table at the top or at the bottom if this helps compressing most of the columns. So what the engine does during the compression tries to change the sort order of the rows in the table and find which one is the best sort order for the compression. Guess what? On average, if you had the case of the column with two values, yes, no, it's a good idea to get all the rows yes and then all the rows with no, because this way the column will be very, 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 very small. And usually the algorithm tries to sort by using the columns that have the lowest cardinality. Guess what? The store key has only 3 unique values. Indeed, the size in memory is just 8 kilobytes. In 8 kilobytes, we store 12 million rows. How is it possible? Oh, we have 4 million rows with the same value, then 4 million rows with the same value, something like that. Maybe not 4, but And so this is the trick that is used. Now, you don't have to do anything. This is already automatically done by the engine. But if something strange happens, you can see the effect of something strange here. So the idea is that now I have an idea about how the compression works and why these sides could be so different. Now, the column size is the size of the column, including everything. However, the size of the column is the sum of three different values. 1, data. 2, dictionary, which is not present in all the columns. When you see 120, it means that the dictionary is not there. 3rd, hierarchy size. So why we have these different numbers and what is their meaning? Before explaining the dictionary, I have to go back to the slide 1 second. We have seen that one technique to compress the data is to sort the table and find rows, contiguous rows with the same value and compress them with the run length encoding compression. But there is a second technique which is based on a dictionary. This technique is called hash encoding. Hash encoding means the following. If I have this table that has a string, Q1, Q2, Q3, Q4. Now, a string, even though it is just a string with 2 letters, a string in Power BI is always Unicode. So every letter is 2 bytes. And so we have at least 4, if not 6 bytes, because we also need the determination of the string. Now, if you think about this, wait a minute. I have only 4 unique values. So if I create a list of the unique values that I have in the column, this list is called dictionary. So I have the list of the names that I have that are used in the column. What the engine does, it creates the dictionary, and then it replaces the value in each column with an index that points to the dictionary. The index is an integer number that provides the position of the string or the number in the dictionary. And because it's a number that is an integer number, it could be stored in a very small number of bits. For example, if I have only 4 columns, I just need 2 bits to represent 4 unique values, 0, 1, 2, 3. 3 bits I can represent 8 unique values, and so on. And so in 1 byte that has 8 bits, I can store 4 rows, because I have row number 1, row number 2, row number 3, row number 4. So I can compress the index pointed to the dictionary. So this technique is called hash encoding. And there is a section in VertiPaq Analyzer where we can see what is the algorithm that has been used to compress the column. And of course, the 2 techniques are combined together, so the run length encoding can be combined with the hash encoding. If a column doesn't use the hash encoding, we say that it is using the value encoding. So the value, the original integer value, is stored into the column. Now that we know this, go back to DAX Studio. And we can see that the dictionary is not present here. Why? Look at the encoding. Value says this column, called online sales key, doesn't have a dictionary because it is stored as a value with a value encoding, whereas all the other columns are stored with the hash encoding, so we have a dictionary. The dictionary is the list of the values, and because this column is the order number, now despite of the name order number is a string. Look at the data type. Now we know that there is a string. Sometimes the order number contains letter. This is the reason why it is a string. And so the dictionary is the list of all the unique values, all the strings that you could find in this column. And because we have 1,600,000 and something unique values, we have the same number of unique strings. And you can guess that if each string is 10 or 15 bytes, because each, 10 or 15 characters, I think that the order number is, I don't remember, let me check. The order number is this one, where is order number, is this one. So we have 4, 8, 12, some 12 or 13 letters. Now the string in the dictionary is always Unicode, so every letter is 2 bytes, and there is an additional overhead for each string that you have in a dictionary. There are other 20, 24 bytes of overhead, so it's easy that you have to count at least 50 bytes for each string in the dictionary. And if you do the math, we have 56 megabytes to store 1,600,000 unique values. So probably we are around 35, 40, something like that, bytes per string. Okay, so this is explaining me, this is the cost of the dictionary. So what about the data? Well, the data is the compressed value without the dictionary that has the run length encoding of the hash value pointing to the dictionary, or the run length encoding of the value encoding, or just the value without run length encoding or without hash. This is the case for online sales key. Online sales key is an integer value, 1, 2, 3, 4, is a consecutive number, so there will be no reason, there will be no advantage in storing a dictionary for that. And so the value stored as is in the column, so no dictionary, but small compression. 12 million rows, 47 million bytes, around 4 bytes for each value. Actually, if you think about this, the integer here would be an integer at 64 bits, 8 bytes. We only have 4, because what happens in reality, the value encoding tries to squeeze the number of bits required. So if you are not using the range of values that requires 64 bits, and your range of values only requires 32 bits, then it is stored in 32 bits, 4 bytes. If you have a range of values in value encoding of numbers between 1 and 15, you will only consume 4 bits. And so in 1 byte you have 2 rows. And this is automatically done by the engine. You don't have to worry about this. So I still have a problem, because now I understand these 2 numbers, but what about hierarchy size? What is this number? Well, the hierarchy size is something that in Power BI you cannot disable, even though you might never use it. Hierarchy size is what is called the user hierarchy for MDX. I'm not making any mistake, for MDX, which is the language used by Excel to query the model, to display the value when you use that column as a filter or as an aggregation. Now, in the latest version of DAX, this structure is also used to optimize searches that you could do over this column in DAX. But if you just use the column to do a sum, this value is never used. Okay, so if you have a hidden column that you only use to use a sum, imagine you have a price, you have a quantity, the column hierarchy size is never used. The column hierarchy size is only used when you put the column in the rows, columns, filters of a pivot table in MDX, or if you do some search of values in DAX. Which means that maybe I could get rid of this column, and you can in analysis services. You cannot today remove this hierarchy size in Power BI. Now, in Tabular Editor, we could try to, but it is certainly not supported. So one day we could do that. And this could be important because sometimes you have columns that are very expensive. For this hierarchy size, you never use it, so you could get rid of that. And for analysis services, big data models, you can. There is a setting to remove this information. Now, as you can realize, what is this? What is the content of this this column? Actually, even though you have a number, this structure contains strings representing the number sorted according to the sort order of the column, and that's it. So basically, it could be expensive. Sometimes this is larger than the dictionary. Sometimes it is larger than other things. So in this case, you see that the value is not larger than the order number here. So there is some compression for the string here, but it's actually very large for this number, which is the online sales key that we never use in any report, by the way. So now you have the knowledge, you should have the knowledge to understand how the column size is computed. The column size is the sum of the data, compressed data, the dictionary, and the hierarchy size. And the larger the number of unique values, the larger the size of the hierarchy size and the dictionary. Now, hierarchy size and dictionary are also affected by the length of the strings you have. So if you have field notes in a table, and notes could be 2 kilobytes, 2,000 rows, 2,000 bytes of text, it's a drama. It's a nightmare. But if the notes are only in one document every 10,000 rows, maybe that you can afford it. But the problem is that if you import a lot of data in a text, the problem is not the compression, the problem is the dictionary. So the problem is how many unique strings you have in the column. So encoding tells me what is the encoding technique. You cannot change it. You could try to enforce the value encoding in analysis services, not in Power BI. The data type tells you what is the data type of the column, of course. What is interesting?
Sorry,
yeah.
Sorry, interrupt again. A question from Donald. How about, I think this is related to the hierarchy dictionary size you explained. How about when setting is available in MDX to false in tabular editor?
The hierarchy size?
Yeah, I guess because at that time is the time we got the question. Or
there is the setting is called I show you. If I go to Tabulator is another tool you can open here, and I go to tables, sales, and let me see, order number. Okay. This property available in MDX by default is true, which means we want to use this column in MDX to group data. If I set this to false, what I'm asking is don't create this structure for my column. Now, I never tried to change this column in Power BI. I know that Microsoft don't support this, what I'm doing. Now, if I save this change and I refresh the model, I could try to see whether the structure for MDX is not saved. It could be a bad idea because, as I said, especially for the strings, if the column is visible in the model, the structure that is created for MDX is also used to optimize the searches. And so actually there is it's like having an index over the column. Otherwise, you always have a sequential scan of the column if you're looking for a number, for a value. But this setting definitely makes sense when you have a column that is hidden and is also only used in a measure, like a sum of quantity, sum of something. Okay, so in that case, it makes sense to hide a column and to remove the empty. So you could save. But usually this is useful for very large models. Usually for Power BI models with 10, 20 million rows, not so much.
Great.
The thing is, you probably want to remove the column. If you don't need that column, the easiest way to optimize the model is to remove the column, which is what I'm going to do in a moment. Now, what I wanted to show you before moving forward is that the dictionary, I mean, many people think, okay, the dictionary is obvious. If you have strings, you have the dictionary. it is less obvious that you have a dictionary even though the column is an integer or a double or a datetime. So the dictionary is oftentimes the best way to compress the data, because you have integer values in a column, but you have 10, 25, 48. So the idea, having the dictionary, all the unique values are stored in a list of unique values, and they are replaced with an integer value that starts from 0 and goes to a number, but only using the bits that are required. And so these bits that are saved are used for other rows, and at the end, this is another level of compression you can achieve. And there is another setting to try to enforce the value encoding. Again, it's not supported for Power BI, but if you publish to Power BI Premium, it works. Which is this, encoding hint. You can say, my suggestion for this column is hash encoding or value encoding. Now, if you ask the value encoding for a column that cannot be stored as a value encoding, the engine will re-encode the column as hash encoding. There are a number of constraints, so even though the column is a number, it could not satisfy the value encoding for a number of reasons. Okay, so you have to look into the documentation, or in our book there is an entire chapter discussing these things. But for Power BI, you never do. You never want to change these values. But this is useful to know what you are doing. Okay. Now,
sorry again, interrupt.
No,
Another
go ahead.
question.
Go ahead,
from Nicola. What are like best practices regarding ordering columns to get the most benefit from RLE compression? Does it? I guess the question is that does it really matter
Yes.
how you order it to get a better RLE outcome?
How much time we have? Not much. So
30 minutes.
It's complex because the official answer, no, doesn't matter. The real answer, it depends. Because, as you can imagine, the compression depends on the ability of the engine to sort the rows, obtaining the best compression. So, in an ideal world, it doesn't matter what is the order that you provide, because the engine will find the best sort order in memory. Okay, so this is the theory. But the reality is different. First, the engine has a limited amount of time to try to sort the data. You can know if this time has been exceeded. How? Let me just, so I have to optimize the time. I can export the information with export matrix here, and I can save this into, let's say, Contoso test. Okay. Now I'm gonna open the tool that is called VertiPaq Analyzer. VertiPaq, let me just VertiPaq Analyzer here, which is a tool that you can download from the link that I showed you at the beginning, but you just search VertiPaq Analyzer, you can download this file that I'm opening in now. And I can import in this Excel file the VPAX file that I just exported. The VPAX file is a very small file, just 20, 30 kilobytes of data, which is just a zip file with just the statistics that you see here and some additional information. So now that I have, where is my VertiPaq Analyzer? Here we go. So this is my VertiPaq Analyzer. You see there is a special ribbon, open VPAX file, and I open the file that I just exported. The reason why I'm showing you this is because the information for the tables view are the same that you can see in DAX Studio, so there is no need to use this for that. But as you see, there are an additional number of tabs here. And as soon as we have the data in memory, I will show you that there are additional information about the compression for each segment, for each partition, and we can check whether the state of the segment is telling me that the time was exceeded. So there is a special warning in a column that can tell you, oh, I didn't have time to test all the possible how to say, all the possible combination. And let me see if I can find the column that I'm looking for, because I don't remember exactly where it is. I think encoding, no, there is an additional column, probably is more fields, and there is state. So state here, let me put the state here, okay, state is ready, and of course in this model I don't have the problem. But there is another state that is time boxed, something like that, that tells you that that particular segment has been compressed without testing all the possible combination, because there is a timeout that you can set. Now, when this could happen, when you have a table that has hundreds of columns. If you have a table that has a lot of columns, it could not have enough time to test to find the best sort order. In that case, time boxed, you could sort the data that you provided to the partition so that the data is already sorted according to a criteria that you know is good for getting a better compression. You have to know what is this idea, because you have to put the larger number of rows that have same values in contiguous rows. And you know the distribution of data. Usually you start from the column that has the lower number of unique values, but sometimes it is not enough. Sometimes you have to do something strange. The other problem is that the compression doesn't happen for the entire table. For example, and let me go back to DAX Studio because it's easier here. You see here that the table sales has 12 million rows, but has one partition and 12 segments. What is a segment? The segment is the minimal unit of compression for a table. When you read the data, when you import the data are imported in memory uncompressed. How many rows? In Power BI, 1 million rows at a time. That is a segment. 1 million rows, compression, store the data. 1 million rows, compression, store the data. One segment at a time, the table is compressed. If you use analysis services, the default is 8 million rows. 1 million rows means that the sort order is tried across 1 million rows. But if you have a larger window, 8 million rows, you might find better compression. Analysis services usually has better compression because you can compress at 8 million rows. Analysis services can be customized. You can change the segment size. Power BI cannot be customized. So you cannot change the segment size in Power BI and in Power BI Premium. I hope that this will change because this could be important in large models with hundreds of millions of rows. And this is especially important for Power BI Premium, in my opinion. So, now, I spent a lot of time here because this was the more important part. And why this is so important? Now, if you look at the, now I spent a lot of time looking at the details, but if you look at the, from a very high level point of view, you can see with this small bar chart, you immediately recognize that these are the most expensive columns of the model. And here you also have a very important information. That first two columns are more than half the size of the table sales and more than half of the entire database. When you have many tables, you might want to see the same information in this visualization where you see the ranking of every column in the model. So we have table name and column name, but at this point you can see columns of different tables in the same sort order. The other columns are identical to tables. Tables and columns show the same data. Here they are grouped by table. Here they are not grouped by table. And this is enough to make an important decision. I have two columns that cost 50% of my memory. And at least one of these two columns is a column I don't use. I never use online key. I just imported the column because it was there. So the easiest thing you can do, you can go back to Contoso. You can go to the definition here of the column online key and you delete. Yes, of course. Deleting a column doesn't require to reprocess. So for this reason, I'm doing this now. And if I go back to DAX Studio and I refresh the view metrics, you will see that now the cost of the table is no longer 300 megabytes, but around 214 megabytes. And if I go to summary, you can see that the size of the model, I saved 30% of the size of the model. Now you have to make a decision, which is, do I really need my order number? Because the order number, I have a user that wants to see the order number. Okay, but this is 80 megabytes. Is 40% of my database now, 37% of my database. If you pay the storage, you have analysis services, or if you go over the limit of the size of a model in Power BI, you may decide that, okay, it would be nice, but I can remove it. Or you could try to store this order number in a way that saves data, because if you take a look, the order number is 80 megabytes, but only 12 megabytes is data. We have 56 megabytes of dictionary and 13 megabytes of hierarchy. Maybe you can try to store this as a number instead of as a string, and you can try to remove the dictionary, for example. This is something you can try to do. So there are, or you can split this into two columns so that you have, the high part and the low part of the order number in two different strings. We duplicate it, and I can try to reduce the cardinality because this will reduce also the dictionary. So there are several techniques you can use to try to squeeze the size of the memory of these columns. Now, with this information, you can already save memory. And saving memory also means saving processing time, because if you reduce the size of the data that you have to compress, you also reduce the memory pressure during process and the time required to process data. But there is something more. Relationships provides you information about the relationship with a very important information, the cardinality of the relationships. Why? Cardinality is a problem in your model when this number goes above 1 million. And when you see relationships above 200,000, you already know you're in a yellow area, but above 1 million rows, 1 million unique values, you definitely have performance issues. Absolutely. You have every query running on that traversing that relationship. It takes hundreds of milliseconds instead of tens of milliseconds. When you have many visuals, a lot of seconds. So you can pay attention to this, and when you detect a relationship that is expensive, you have to be very careful in using that relationship in your model. Partitions is something that you cannot use much because in Power BI. Because in Power BI, you cannot define partition unless you use incremental refresh. But at that point, the partitions are only published in Power BI. So if you have Power BI Premium, you can use DAX Studio connected to the XMLA endpoint. Otherwise, unfortunately, you cannot. Then with this information, you already have something that is useful to understand your model. But as I said, VertiPaq Analyzer then provides you additional details. For example, you see that for the compression, we can see the number of the columns compressed by the number of bits of each column. You can see other information about the data types. You can see the information about the encoding. You can see information about the state of the compression. So we have a lot of information that usually are not useful for Power BI. If you have models above 1 billion rows, you definitely want to spend some hours looking at this data, because you can save at that point hundreds of gigabytes. Not giga. You can save gigabytes and gigabytes just playing with some small optimization. Whereas in Power BI with 20, 30, 40 million rows, at the end of the day, you cannot save much. So it doesn't make sense to spend time on this stuff. So let me go back to the slide 1 second. So I think that I quickly shown you this different compression, hash encoding, random encoding. The segmentation is what I was saying about the segment size. So you see the information about the segments, and a segment is also the minimal unit for allocating data in memory. Sometimes having this information also for Power BI is useful, because when you see a table, I show you, I have a model here. I should have a model here. Let me check. Here we go. This model has, in this table, audience, 4 billion rows. I have a Power BI file with 4 billion rows. It doesn't, I mean, you should not have the file like that, but this is just for the demo. And if I open here DAX Studio, and I open, I think I already opened DAX Studio before. No, I don't have this here. So if I open DAX Studio here, I go to Advanced and I go to View Metrics, I will show you huge numbers of data, of segments, and so on. And I wanted to do that because if you recognize something that has, I mean, this case is exaggerated because we have 3,000 segments in this case, which is a very, very big number. But when you have hundreds of segments, you know that every query spend time just managing all these segments. But as you see, this is an example where we have a model that is 10 gigabytes in RAM. Power BI Desktop can have. I can never publish this, but I can work locally. And here I have the distribution of the data in my columns. Here, in this case, every detail counts, and every single bit that I can save, when you have 4 billion rows, saving 1 byte for each row means 4 gigabytes. So you can imagine we pay attention to every detail here. And so this is just to show that the tool is the same, and we can also work with much, much bigger data models. And the segment is this minimal location of data that is important for the query, but especially important for the process. And the segment is also part of a partition if you have partitions. And this could be important if you use the incremental refresh, because incremental refresh creates a partition, one partition for each element of the granularity of your partition. So if you go at the day level, you might have one partition per day, which could reduce the size of the segment because the partition is a boundary for a segment. And you cannot have a segment that is across multiple partitions. So the partition is a limit that says, okay, the segment cannot be larger than one partition. And so creating two small partitions could increase the number of segments too much. Remember, in Power BI, you don't want to have a lot of small segments, where small is 10, let's say 50,000 rows, 10,000 rows, and you have many segments like that because you created small partitions. Not a good idea for the performance, especially for the query performance. Relationships, the reason I said the relationship should not be so large, there is an explanation of this, but you can find a better explanation in the definitive guide to DAX about this. The relationship is a structure, is like an index that tells you how to retrieve the data from another table. When this relationship has a lot of unique values, this structure is very big, and it becomes inefficient to use when you join tables or when you combine data between tables that are involved in the same aggregation. So there is an explanation of the reason why this is so important, explaining when you apply a filter, the rows corresponding to the filter are used, transferred, and then applied as a filter to another table. So basically, it transfers the filter from one table to another, but this could have a cost that depends on the number of unique values you have in the relationship that are involved in the filter. And that's the reason why the larger this number, the slower the performance. Slower when we have more than 1-2 million rows in the cardinality of the relationship. Okay. So I have the slide for analysis services usually. How big is big? So in Power BI, with 10 million rows, usually life is good, but in Power BI, we want to spend some time removing the unnecessary columns because you can save a lot of space. 100 million rows, pay attention to DAX because even though the compression is good, if you create iterations that takes too much time, you want to pay attention to the DAX code. At 1 billion rows, you want to use all the features of VertiPaq Analyzer and save as much as you can. At 10 billion rows, you are in trouble because you don't have enough memory for your model, but at 100 billion rows, you are not able to store the data in memory, even though you get a large analysis services database. And so that's just to give you an idea, and also give you an idea about the time required to scan a column that has the number of rows. At 1 billion rows, every query you run runs in at least 100 milliseconds to 2 seconds is a regular number. When you have 10 million rows, like my model, I expect every storage engine query to run in less than 20 seconds, 20 milliseconds, sorry, 20 milliseconds. Okay, so this is just another information that could be interesting. So all these numbers could help you understanding how to optimize the code, how to optimize the model, how to save memory. The first thing you have to do with the VertiPaq Analyzer, find where you have expensive columns and figure out whether you really need those columns or not. When you say, okay, I need this column, but it's too expensive, try to figure out whether you can reduce the cardinality. And sometimes you can. Sometimes you just import too many details of a floating point number that you don't need. Or you have a lot of unique values in a column that you could remove because 90% of those values are related to transactions you are not interested to. So there are many things you can do once you know your model. And so these tools helps you get in the numbers to make the right decision. That's the idea.
Great, thank you, Marco.
Yeah.
We have some questions, but
yes,
we don't have much time to go through all of those. I'll just mention two of them because they have been waiting for a long time.
Yes.
Yazan asking that there was something called RI violation in the metrics that you have shown, and at some point he have seen that, or she has seen that this was red. So can you explain a little bit about that?
Very quickly, there is an explanation somewhere in an article, I don't remember where, but the idea, there is a Phil Seamark article about a better explanation of the meaning of this. The idea is the following. When you see this number that is not 0, it means that on the many side of a relationship, you have a value that does not exist on the one side of a relationship. This is called a referential integrity violation. Now, it is not an error. It is not something that stops you using the model, but it tells you two things. First, you might have a data quality problem. Second, certain queries could be affected by the presence of the RI violation. Now, in my experience, the performance issue is very rare. Okay, it could be possible, but if you read the article written by Phil Seamark, it is not really something that should happen often, right? But the presence of that usually tells me another thing. Especially if I didn't expect that, I have some problem in my data, or in my Power Query, or in my SQL query. Okay, and probably I want to spend time understanding why I have a bad data in my model. Okay, so that's the idea.
Great, thank you. Another question from Reddick and Fernando both. They are saying that at some scenarios they can't really remove like that ID column because they need it to be searched by user and things like that. What are alternative approaches they have if they have a really high cardinality column that they can't remove, and how they can improve the size of model considering that?
Tell the customer the price. of that column. No, really, seriously. Seriously. If that column is 50% of the storage, and you are, for example, you're in an easy case is this afternoon I helped a customer, and I said, look, you have these 4 columns are 50% of the database, and they asked me to optimize the model so they don't have to scale to the next tier of analysis services because it is more expensive. And I said, okay, look, I solved the problem in the short term with this setting because we can paginate and we can solve the problem at the moment. But do you really need these columns? Because look, these are translation of a column of the product name in 4, 5 different languages. If you need it, it's, of course, but this cost, it is doubling the cost of the model. So if you ask me, I don't want to scale up. Okay, ask to your users if they're going to pay double the price because they want the translation in 5 languages. That's it. So it's simple. And I think that it is the same problem. As long as we don't have a way to selectively load the columns of the model, because the solution for this problem is don't load the data in memory. And when the people want to go to that column, even though it is very slow, go direct query. But it is very slow. So you will never have everything. Okay, so if you want the performance and you want the detail and you want you will never have everything.
Yep, that's a great answer. Thank you for that. One last question. Is not actually about the size of the model. It's about DAX formatter.
Yep.
And is asking, like, what is DAX formatter? Is it similar to DAX Studio? If you can just show that in a simple example, that would be fantastic.
Simple example. The easiest way to do this is the following. If I get, for example, this query, I just wanted to, with a shorter number of clicks, I wanted a query here, and I paste the code. So whatever DAX code you have, this or anything else, okay, now I'm just getting one random this way, okay? So by clicking format query, I call DAX formatter, which is a website that provides a service that format the code in a better, more readable way. We have a different way to format the code. The short line is the standard we use in our article. So the code is more rows, but is simpler to read. Whereas long line, the code is more compact, with a smaller number of lines, what we use in the real world. But when we have to explain, we usually use the other. There are additional settings that you can see here. We have, not much, but we have the default, the long line or short line, and the spacing. You can decide to have no space between this and the parentheses, the name and the parentheses, or you can enable the space if you want. And the same feature that you see here, even though you don't use DAX Studio, you can go to internet, to the internet website at daxformatter.com. that sooner or later will appear, and this shows me the same service online. So you can paste the code here, and you can do, now I'm doing this with a query, but it will work also, oh come on, it will work also with the definition of a measure. You can copy the measure definition or the table definition that you have in Power BI, you paste the code here, you format, and you copy and paste back.
Great, fantastic. Thank you for explanation. And anyone, if you have questions further on these subjects, feel free to contact Marco directly through SQL BI website. And I, again, recommend checking out their materials, a lot of useful materials in their website. Thank you, Marco, for presenting. Any last
Thank you
words?
very much. It was a pleasure to present. Have a good day. It's early in the morning, right?
Yeah, it's not that early anymore, but
Yeah,
it is quite late evening for you. Okay,
Yes.
thank you. Thank
Thank
you
you
for
very much.
your time. Thank you, everyone, for joining.
Thank you very
See ya.
much. Bye-bye. Bye-bye.